Hello. Thank you for joining us today. Good afternoon. This is extending data centers to the cloud, connectivity options, and considerations for hybrid environments. My name is Benjamin Felden, and with me here today is Sid Chawan. Both Sid and I are solutions architects with Amazon Web Services, and we are based out of New York. I'd like to start by setting the context for today's talk. As solutions architects, both Sid and I have daily conversations with customers. And in those conversations, they talk to us about their requirements for connecting their data centers with the footprint that they have running in AWS. And these conversations tend to have recurring themes or common questions that tend to come up. And so we thought we'd like to address those questions and themes today. This talk is intended for cloud architects, network engineers, and any app owners that have a vested interest in how their apps are connected to AWS. So what we'll be covering today is what is it that we mean when we talk about hybrid environments? And what are the AWS services that come into play to make that connectivity possible? Then we'll do an architecture view of what these different options consist of, what they look like, what they should mean to you, and then sort of zoom in to look at the functionality that's provided from this connectivity, or in other words, what are we connecting to? This talk is a 300-level talk. It assumes a basic understanding of VPC and some basic network functionality, so we hope that you've had a chance to already set up a VPC or perhaps have attended NET305, a talk that was presented earlier called Creating Your Virtual Data Center. At the end of this talk, I hope that you leave here with a strong handle on what are the different options for connecting into AWS that there are for you to leverage, and that you'll be able to map between your workloads and what is most appropriate for them and in order to meet your business goals, and in a way where you can design a robust and redundant connectivity to AWS. And ideally, if this talk has served you well, you leave here being able to make informed decision about what is the right way to extend into AWS and turn it into part of your global infrastructure. And time pending, I will also be covering what is the meaning of life. So let's begin with a quick level setting of terminology. When we refer to hybrid environments, we are actually talking about customers that have requirements for storing data in AWS or running compute loads in AWS, and they wish to connect them with storage and compute workloads that are running elsewhere. This could be in the customer's self-owned, self-managed data centers, or in co-locations where racks are being leased, or external platform as a service that is outside of AWS. There are really many use cases where this becomes a necessity. If you've been to the keynote this morning, you've heard Andy talk about this in the context of VMware. So many use cases where we see this happening. For example, you could be running certain elements of an application in AWS and then certain elements of the same application outside. You could be feeding your applications in AWS with data streams or database replications. You could be relying on AWS as a reliable off-site storage for backups and archiving. You may be running Amazon Workspaces as your chosen VDI solution or desktops in the cloud. And then those workspaces require connectivity to back office applications that are running in your data centers. You may be looking at AWS as a disaster recovery site that provides you with some geographic diversity between your locations. And you may be doing all of these things perhaps at the same time. So one way or another, these use cases are relevant to virtually all enterprises because they tend to have their servers and their data dispersed between multiple locations. So customers are asking that they be able to leverage the same tools and methodologies across all of their sites and look at AWS like any other data center that they control. So all of this connectivity is enabled by essentially three services: VPC, VPN, and Direct Connect. and we'll be talking about those today. In the context of VPN, our focus will be mainly on IPsec VPN. IPsec VPN will authenticate and encrypt IP packets. And IPsec VPN on AWS really breaks down into two main options. The first is AWS Managed VPN, which you'll see referred to in the documentation as hardware VPN. And this provides you with very simple, quick, a secure encrypted connection into a VPC. And then there's software VPN, which is essentially running a virtual VPN appliance on an EC2 instance. And then you are responsible for installing and managing the software and maintaining the tunnels. So there's pros and cons for both approaches, and we'll be talking about those today. And then there's Direct Connect, which you will sometimes see abbreviated as DX. This is a service that we've been offering since 2011. And this provides you with a private physical link into an AWS region. And you do this by connecting with us at one of 42 locations around the world. Direct Connect gives you consistent performance, private end-to-end, which means it does not traverse the internet at any point. And then you're not susceptible to internet weather type events. Let's look at some of the locations where Direct Connect points of presence are around the world. These are large co-locations that, where AWS has already set up equipment and redundant connectivity to its backbone and are ready for you to establish a Direct Connect link. You will see that each location maps to one AWS region. Now, you may have seen this slide last year at reInvent, and if so, you'll notice that between the new Direct Connect locations that have been added and the new AWS regions that have come online with Direct Connect out of the gate, there are a lot more options to choose from now. Some more of the locations, Direct Connect actually is offered in all 14 of the AWS regions around the world. Generally speaking, there are at least 2 Direct Connect locations for each AWS region. And keep that piece of information in the back of your mind because we will be referring to it a little bit later on. All right, so we kind of now understand the need for hybrid connectivity, and we're aware of the AWS offerings that make that possible. Let's begin to draw out what this looks like. And for each option, we'll kind of dig into what it means. Let's begin with what we already know. On the one hand, you have your corporate data centers. And this can be any of the options that we mentioned, a self-owned, self-managed data center, or a colo space. The assumption here is that you own and control the networks in that environment that you wish to connect to. So let's add a router to that end. And then on the other hand, we have the AWS region, which probably has one or more VPCs, as well as AWS services that are publicly addressable. So services like S3 or DynamoDB or SCS or SNS, etc. Now, our conversation today is about how do you connect these two together. So let's slide them a little bit to the side and be able to focus on what's in the middle. So we will add a representation of the internet. The AWS region is connected to the internet with redundant connections and capacity to meet the entire region's demand. And the corporate data centers are likely also connected to the internet, hopefully with some resiliency in mind as well.
Benjamin briefly mentioned that you have 2 options to connect your data centers to AWS using IPsec VPN over public internet. Let's dig into what these options are and the advantages of using one or the other. Option 1 is AWS Managed VPN. In this option, AWS fully manages the VPN termination endpoint at the AWS side. This endpoint is called the Virtual Private Gateway, abbreviated as VGW. Like other AWS managed service definitions, what this means is that AWS will take care of the underlying VPN infrastructure as well as high availability. VGW is a region-wide resource. It can sustain availability zone failure, without performance degradation. It's a resource unique to a VPC. What this means is that for every VPC will require its own virtual private gateway for the purpose of VPN termination. At the customer side, also referred to as the remote side, we have the customer gateway, abbreviated as CGW. CGW is a representation of the physical device or the virtual appliance at the customer end, terminating the VPN connection. These are some of the features supported as part of the AWS Managed VPN offering. Last year, we added support for latest cryptographic features like AES 256, SHA-2, as well as support for NAT traversal. Setting up VPN is quick and simple. Using AWS Management Console or API call, you can create a VPN connection. Our Management Console will automatically generate a configuration file which you can download and apply on your router. We support most common vendors like Juniper, Palo Alto, Cisco. And if your vendor is not listed there, just download a generic configuration file and use that to configure your router. So once you do that and you configure your router, a VPN connection will be up and terminated on the virtual private gateway. From a routing perspective, you can set up static routes, or you can use BGP for dynamic routing. Now, if you look carefully at the VPN configuration file you download from the AWS Management Console, you'll see that virtual private gateway is represented by two publicly routable endpoints. This is how we achieve high availability. So when you create the VPN connection, you're actually creating two VPN tunnels, one per endpoint. This is not a configurable thing and is baked into the service and should give you an idea of how seriously we take high availability. But if you wish to do so, you can just bring up one tunnel and still the traffic flow will happen and the VPN connection will work. But if you want a VPN connection which is highly available and resistant to availability zone failure, we strongly encourage that you use both the tunnels to both the endpoints. So one VPN connection equals two VPN tunnels. It's important to remember this fact. Now, we recommend that you think about resiliency at your end as well. So for the purposes of high availability, we'll have a second physical router at your end. Now, based on how your data centers are connected, you might be in a better state of resiliency if the second physical router was in a second physical data center. You'll bring up a second VPN connection from the second physical device to the same virtual private gateway. We mentioned two VPN tunnels per VPN connection. So a total of 4 VPN tunnels when leveraging high availability at AWS end, which is out of the box, and considering resiliency at your end as well. If high availability is important to you, this is the state you want to be in when setting up VPN connection to a single VPC. So once both the VPN connections are created, established, traffic is flowing, traffic is gonna flow only through one of these. And you have the ability to influence which VPN connection is used for the traffic flow in both directions. And this is influenced on a per network basis using BGP routing options. But for a given network, think of this as an active standby scenario where only one VPN connection will be used for traffic. So if the primary experiences any issues, traffic can automatically be redirected and will flow through the second VPN connection. This is the kind of routing you should be looking to establish. So now we know what's involved with creating a highly available VPN connection to a single VPC. Now, to create a connection to the second VPC, we repeat the exact same steps. If you remember, we mentioned that virtual private gateway is a resource unique to a VPC. So for VPN, we'll bring up a second virtual private gateway, create a pair of VPN connections, reusing the existing customer gateways to the second virtual private gateway. We have 4 VPN tunnels per VPC, a total of 8 VPN tunnels. You can repeat these steps for as many VPCs as you want to connect to. So just keep these steps and this architecture in mind. Let's summarize. AWS Managed VPN. Simple and quick to set up. Latest cryptographic features. Out-of-the-box high availability. And we encourage you to think about availability at your end as well. You pay 5 cents per VPN connection hour. This consists of both the VPN tunnels. Whether you use them or not, you're paying 5 cents per VPN connection hour. From a performance standpoint, you can get multi-gigs per second per VPC. So this is limited at a per VPC level. So all VPN connections to a VPC cumulatively share this performance metric. Now let's move to option number 2. An alternative to using AWS Managed VPN is to use VPN virtual appliances to terminate VPN connection on an EC2 instance. Many cases in which our customers go with this option is because they are looking for consistency in their VPN provider of choice across all their sites. Or they might be looking for a particular feature which is proprietary to a vendor, like Cisco DMVPN or the Sophos Unified Threat Management. Now, to set it up, you'll have to create an EC2 instance in the VPC where you want access to. Make sure you have internet gateway attached to this VPC, and this EC2 instance is reachable over the public internet using Elastic IP. Next, you'll deploy a VPN software on this EC2 instance. This can be an open source software like OpenSwan, or this can be a vendor software like Juniper, Palo Alto, Cisco. You can also use Marketplace to one-click deploy vendor software, which will automate most of these deployment tasks for you, making it extremely simple. Now, unlike AWS Managed VPN, customer has to think and manage about high availability. So, for the purposes of high availability, let's bring a second EC2 instance. You will have to create a simple automation around these 2 EC2 instances so that in case the primary instance fails, the VPC route table can be automatically updated to point to the second EC2 instance for all VPN traffic. Now, some of the vendor products have this automation built in, so if you're using their products, you don't have to create the automation from scratch, and you can leverage their built-in automation. We strongly encourage you to think about high availability at your end as well. So we'll create 2 VPN tunnels, 1 per EC2 instance, and we'll have to manage and monitor the availability of these endpoints and these VPN tunnels. And in case one of the VPN tunnels experiences any issues, that's when the automation will kick in and the failover will happen. There is a little delay associated with the failover, and we typically see failover times which is greater than what you would see in the case of AWS Managed VPN. Now, before we wrap things up, we would like to briefly call out a reference architecture we published earlier this year called the Transit VPC. This solution should give you an idea of the advanced architectures that can be created using software VPN on EC2. So using software VPN appliances like Cisco CSR, we can build a global backbone of VPN connections over public internet, connecting multiple locations. A location can be a customer site or a VPC. Using automation built into the solution, you can deploy a transit VPC in a region of your choice, pre-configured, and you can automatically attach the VPCs in that region to the transit VPC. A customer site, like the global headquarters or the branch, can connect to the transit VPC using Direct Connect or VPN. All transit VPCs are meshed together using IPsec VPN, creating this global VPN backbone. Traffic between locations, no matter where they are globally, will be backhauled through this global VPN. We'll not go into further details, but we strongly encourage that you visit the AWS website and have a close look at the reference architecture. We will also be covering this in other networking sessions this week, details of which we will call out at the end of the session. So let's recap. Software VPN on EC2. You install an open source or a vendor software on an EC2 instance. Can be leveraged to create advanced architectures like the transit VPC. Customer has to think about high availability both at AWS side and their end, although there are automations to help you with that. You pay for vendor licensing and EC2 instance costs. From a performance point of view, it is determined by the EC2 instance size and type. And if you're using one of our beefier instances, you can easily get multi-gigabits per second per EC2 instance.
All right. So we know what's involved with the VPN options. Let's begin to talk about Direct Connect. And the conversation here starts with an ask from customers that they be able to truly leverage their cloud resources in the same way that they leverage resources in their own data centers. And that requires a similar type of connectivity to the one that enterprises have come to expect between their different locations. So that means private end-to-end connectivity does not traverse the internet, a consistent and optimal network experience throughout. And that is defined by a known amount of hops along the way, or a known amount of pieces of hardware along the way. And you have some form of business relationship with every entity that makes up that entire path, which becomes very, very critical when you're troubleshooting any kind of network issue. So what does this look like? How do we get this up and running? You may be aware that AWS does not disclose the locations of its regions, but we do tell you exactly where you can come and meet us to form a direct connection, and we invite you to do so. So I'm referring to the list of locations that we looked at before in the slide maps, 42 locations around the world currently, and typically there are several per regions, as mentioned. And these are large co-locations where we are already established, which means that we have already installed routers that we own and operate in cages in those co-locations and have connected between those routers and our region's network backbone. To be clear, these locations are not where the regions are or where a specific availability zone is. They are external to the region. Now, once you've identified which region you'd like to connect to and which Direct Connect location you would like to connect through, we need to establish physical connectivity. There sometimes is a little bit of confusion around the different options that there are in order to establish this physical connectivity, and I'll try to clear those up today. There are two important things to remember, though, overall. By definition, if you enter an AWS region through a physical connection, you will be going through one of these 42 locations. There is no other magical entry point into an AWS region. The other thing is that there is going to be at least one more entity besides the customer in AWS to make this connectivity possible, and there may be more than one. And I think that's where some of the confusion stems from, so let's try to clear all of this up today. I'll be discussing three options. Option number one is relevant if you already have presence in one of the co-locations where we offer Direct Connect. Option number two is if you do not. And in that case, you will engage with a partner or a network provider that will build out a circuit between your data centers or your locations and that co-location. And option number three is relevant if you are already engaged with a service provider that is running a managed network. that connects different locations that you have, and you would like to extend that managed network to include an AWS region. So let's review these three options. And we begin with the simplest option, which is if you have presence in one of these co-locations, in which case you likely have a router there. And if that is the case, Direct Connect cannot be simpler. You simply log onto your account, order a Direct Connect port. You need to tell us which co-location you are in, and if you're interested in a 1 gigabit or a 10 gigabit port. And that's it. Those are the questions that you will be asked. And that triggers a process that could take up to 72 hours, but typically takes much, much less, at the end of which you receive an LOA, a letter of authorization. This LOA means that we have allocated a port solely for you on our routers, and you are now authorized to connect to that port whenever you're ready. At this point, all you have to do is take that LOA, provide it to the co-location provider, and request a cross-connect between your router and the port that's mentioned in the LOA. When that cross-connect is established between your routers and ours, you're physically connected to AWS. And you now have the control to create virtual interfaces on top of that connection. But hold on to that thought. We'll be covering that in detail a little bit later on. For now, let's continue talking about the different options for physically connecting. So what if you don't have any presence in any of the Direct Connect locations? That's not a problem. You will actually go through the same process of ordering a 1 or a 10 gig port, receive the LOA, but now you need to engage with a network provider that will build you out a circuit between the data center that you own, between where your networking equipment is, all the way to the co-location and to the port that is allocated to you. We have a list of APN partners supporting Direct Connect that is available online. These are partners that are well-versed in building out circuits into some or all of the Direct Connect locations. If you're already working with network providers, even if they're not on these lists, ask them if they're able to build you such a circuit into the Direct Connect location of your choice. Now, what will happen is they will have some piece of hardware at the co-location, and they will extend layer 2 connectivity between the port that's mentioned in the LOA and the router in your data center. There are different technologies by which this can be achieved, but sort of a common name for all of them is pseudo-wire, right? We're extending a long wire between these two pieces of equipment. Now, there's a special case of this option, option number 2, which I should mention, and that is if you are engaged with one of our partners and you wish to connect to Direct Connect, you can actually order a sub 1 gigabit port. And we offer port speed of 50, 100, 200, 300, 400, and 500 megabits per second. So in the back end, these partners have pre-built either 1 or 10 gig ports and are slicing them up for customers to take advantage of. The third option is relevant for customers that may already be engaging with a large network provider to connect different locations that they have around the world. And sometimes this is achieved by MPLS, and sometimes with different technologies. If you are connected through such a service provider operated network that links multiple of your locations, you may be able to add a Direct Connect location into that same MPLS network. Many large providers are also partners of ours, and they offer a managed solution. So you may recognize brand names like AT&T NetBond, or Verizon SCI, or Level 3 Cloud Connect, or Equinix Cloud Exchange. When you use these options, the AWS region becomes another location in your MPLS network. So as you're evaluating the different options that there are for physically connecting into AWS, and based on what we've talked about today, I want you to think about these questions. I want you to keep these questions in mind. In whose account will the Direct Connect port be created? And then what does the process look like to create additional virtual interfaces for the purposes of adding additional VPCs? Who is responsible for routing between the AWS networks and the customer networks? And what are the overall costs that are associated with this connectivity type? So with those questions in mind, let's recap the three options that we talked about. In option 1, you order the Direct Connect port in your account, and then you create and remove virtual interfaces as you see fit, connecting into multiple VPCs. You are responsible for the routing end-to-end, and the cost that is associated with this is the port charge based on 1 or 10 gigs, data transfer charges that are based on actual usage, and then option 2 is almost identical to option 1, but with 2 important notes. Now you are also covering the cost of extending that circuit between your data center and the colo, and that is between you and your provider. And the second thing is, if you are using that sub 1 gigabit option, while it is you who creates the virtual interface, you can only create 1. So essentially, that limits connectivity into 1 VPC. And so if you are using those sub 1 gig options, you'll need to create multiple connections for multiple VPCs. The connection is still in your account in option 2. You are still responsible for routing, and you still pay a port fee on top of the data transfer fees. And it's really in option 3 where those questions that I mentioned are most important. Because your provider may be offering you an option where the Direct Connect port is in your account, and they simply are delivering that into your MPLS network. Or they could be connecting their own Direct Connect ports into your network and offering you a managed slice of that. And if that is the case, if they own the Direct Connect port, the process of managing virtual interfaces is now between you and them, and they act on your behalf. Now, they may have a portal that automates this process. They may have different pricing models. They may offer you an easy access to multiple AWS regions. And so it's for these reasons that I recommend to be mindful of those questions as you are evaluating the different physical connectivity options. And my overall recommendations would be as follows. If you do not have presence in any of the Direct Connect locations where they're currently being offered, speak to the network providers that you're currently engaged with and ask them if they can offer you connectivity into the AWS region of your choice. And I also recommend that you loop in your AWS solutions architect, so folks like Sid and myself, and have him or her participate in the conversation where you are debating the different options for connecting. Now, we've already brought up cost, so let's discuss a couple of deeper points. You may be aware that data into a region, AWS doesn't charge for it, it's free. Data coming out of the region will differ by region. But it will be less expensive going over Direct Connect than it is going over the internet. And when I say over the internet, I mean what you'll see in the pricing pages as EC2 data out or S3 data out. Those are internet-based data out. When you're conducting comparisons between the two options, you should factor in the hourly port costs, the data out costs, and any circuit costs that were associated with building a circuit into the colo. When you're comparing the VPN option, there's the cost of the VPN, data out, which is now at internet pricing, but also the cost that is associated with egressing to the internet from your data centers. And customers sometimes overlook that, but it should be factored in when you're doing a comparison between options. So we now know about the physical connection options, right? And we have an idea of how to evaluate cost. Let's talk about how we bake resiliency into our Direct Connect solution. So let's assume that we have connected through a co-location, and we've established a cross-connect. What does this look like in terms of redundancy or susceptibility to failure? Well, there are many single points of failure along the way here. And those could essentially disconnect you from your connectivity into AWS. So your router is a single device. It's coming out of a single port. It's connecting through a single cross fiber into a single port in the AWS router, which is also a single device. Now, the AWS router is redundantly connected to the region, but up to it, there are fiber optics that can fail, and line cards, and power supplies, and routers can crash, not to mention human errors. So I'm not saying all of this to make you leave here depressed. It's really because we're working under the assumption that the workloads that you are connecting to are architected based on recommended best practices. And if that's done properly, they are architected to withstand up to an entire availability zone going offline. Our goal here is to match the same type of resiliency in our connectivity option. And so let's think about the option of adding VPN as a backup. So one of the options that Sid talked about before, this is simple. The cost isn't typically considered too bad at all. If you're using the AWS Managed VPN option, we will automatically favor going over Direct Connect rather than VPN to any network that we can access via both. Which means that we inherently think about this, we inherently treat this as a backup solution. So while it is that you're fixing your Direct Connect if it broke for whatever reason, you're relying on VPN. And the VPN connection will be potentially less performant, and it will provide a less consistent network experience. So keep those things in mind when you're architecting the connectivity and the workloads that rely on it. One notch up in terms of resiliency is to add a second Direct Connect link. And when you order a second port to the same co-location through the same AWS account, we will automatically place you on two different pieces of hardware, and that will provide much-needed device redundancy. Now, it's important to note that while you gain device redundancy on the AWS router, you will likely also want device redundancy on your piece of equipment, and that depends on how it is that you're physically connected. So it may mean that you need to add another router in your colo cage, or build a second circuit into and connect it to the same data center. Or perhaps build out that second circuit from a second data center, depending on how your data centers are interconnected. This may offer a higher level of resiliency. As soon as we start talking about two Direct Connect ports used to access the same networks, we should mention how these are used together. And by default, we will multipath between them, which means that we will attempt to use both of them at the same time in an active-active scenario. So what that means is, for example, if you order two 10-gig ports, you can effectively benefit from 20 gigabits of bandwidth. There are cases where customers choose not to do so, and they want to configure this in an active standby scenario. And we typically see that when customers have some form of stateful firewall running on their routers and they wish to maintain state. And if that's the case, you can actually influence which of the connections is being used in both directions. And you do that with BGP settings and routing decisions. So you can actually prefer one connection over the other. Now, we will be covering the implementations of configurations like that at a separate session, and I'll be calling that out at the end. One thing to keep in mind, sometimes customers will add a Direct Connect for resiliency. So they'll add a second connection for the purposes of resiliency, and they'll set it up in an active-active scenario, because why wouldn't you? But over time, they develop a reliance on the aggregate bandwidth that both of these connections are providing. And so what happens is, if one of them fails, the degraded bandwidth that is now available actually causes them business impact. And so the takeaway here is, you should actually be looking at these things periodically. You should be evaluating your performance resiliency standpoint on a regular basis, and you may need to add additional Direct Connect ports as you go on to keep up with your bandwidth requirements. So, while the two AWS routers are on separate pieces of equipment, like we mentioned, they are in fact still in the same physical facility. If the workloads you are supporting are designed to span multiple availability zones, as I hope they are, or in other words, they're designed to withstand an entire facility failure, you haven't actually matched the same level of resiliency by connecting two Direct Connects through the same co-location. And the answer to that problem is to build that second Direct Connect link through a second Direct Connect location that connects to the same region. And that provides you with full facility redundancy with a little bit of geographic diversity. If you remember the map slides that we looked at before, I mentioned that generally we have 2 or more Direct Connect locations for each region, and that is how you go about adding this layer of resiliency. So for example, if you are connected to US East 1 through Equinix and Ashburn, for example, you may consider building out that second connection using CoreSite in either Reston or New York City. And you may choose to build that second connection from a separate data center. And again, this is based on how your data centers are interconnected. So now we are on a properly designed and fully redundant architecture that is designed to mitigate the potential risks of up to a facility failure. However, for good measure, we would still recommend adding a VPN on top of this as an additional layer of redundancy. And again, this VPN won't offer you the same level of performance or the same network experience. It will, in fact, probably give you a degraded level of service, but it is intended as a second line of defense so that you never remain without connectivity, even in the event of multiple failures. Regardless of which resiliency mechanisms you choose to employ, I strongly recommend that you test failure scenarios, and you do so on a periodic basis, because you don't want to find out that there's a specific missing piece of configuration or a specific route. You don't want to find that out at exactly the wrong moment. So let's review Direct Connect as a whole, using the same dimensions that we looked at VPN before. The service is offered currently in every AWS region, all 14 of them, through 42 points of presence around the world. You can expect up to 72 hours to receive your LOA, and probably a longer lead time to build presence or connectivity into the co-location. You add resiliency by adding VPN or adding additional Direct Connect, or better yet, adding additional Direct Connect through a second location. Your cost will consist of the port hours, the data transfer based on usage, and any cost that's associated with building the presence in the colo or getting to the colo. And your performance will be either 1 or 10 gig, or those sub 1 gig options that we mentioned, or an aggregate of multiple connections if you choose to do active-active. And that about sums up the options for connecting into AWS. But before we get into the more logical aspects of this connectivity, let's talk briefly about how we adapt this architecture as we go on. And luckily, this is very simple. The most important takeaway is this is flexible. You can grow and adapt with time. What we see a lot of customers do is they will begin by setting up VPN, typically AWS managed VPN, and then they will commence with building their Direct Connect in parallel. An important note to keep about that is you don't begin to get charged for the Direct Connect ports until the connection between your routers is actually established, or 90 days, whichever comes sooner. So what that means is effectively you are given 3 months of grace where you have the LOA in hand, there is a port that's waiting just for you, but you don't begin to get charged for it until you connect through it. VPN is inherently and immediately considered a backup. You can add additional Direct Connects for either bandwidth or resiliency. You have full control over how the traffic flow works. And if you have any concerns or questions or you need assistance, I recommend that you open up a support case, and they'll be happy to help you with it.
All right. Now we know what the options for connectivity are and how to layer resiliency into our architecture. Let's see how do we use these options to gain access to resources inside AWS. Let's bring in AWS and the resources inside it into a visual. Okay. All right. Let's see what a typical customer's infrastructure looks like before we get into how do we access resources. So typically, we see customers have multiple VPCs. For this discussions, let's say we have production VPC, a test VPC, and a development VPC. In many cases, and we strongly recommend you do so, customers will have multiple accounts. For this discussion, let's say we have a production and a non-production account. Some of you might be familiar with VPC peering, which allows two VPCs to seamlessly talk to each other. Now, if VPC A is peered with VPC B, and VPC B peers with VPC C, some customers assume that A will be able to access resources inside C using these two peering connections. This is transitive routing and is not supported. Okay, so now we know what a typical infrastructure looks like. Let's see how do we access resources over Direct Connect. Benjamin briefly mentioned that you need to create a virtual interface. For accessing a VPC, this is called a private virtual interface. This virtual interface can be easily created using AWS Management Console or using an API call. While doing so, you'll have to specify which VPC you want to connect to and the virtual private gateway associated with this VPC. This is the same virtual private gateway which we talked about during the AWS Managed VPN option. So a virtual private gateway has both Direct Connect as well as VPN components associated with it. The virtual interface is mapped with a VLAN ID. What this means is any traffic destined for resources inside the VPC as it goes from the customer router towards AWS and vice versa will get tagged with a VLAN tag. Within the VLAN, a BGP session is established between the customer router and virtual private gateway. As part of the BGP route advertisements, we will advertise to you the entire VPC's IP range, not a subset, not the subnet range, but the entire VPC range. For routes advertised into the VPC, that's really up to how you configure BGP. But you will be limited to 100 prefixes. So if you wish to advertise more than 100 prefixes, we encourage that you either summarize it or even advertise a default route. You repeat the same steps for every VPC you want to establish connectivity to. Create a virtual interface, map it with a different VLAN ID. Now, the second VPC can belong to the same AWS account that owns the Direct Connect port or a different account, and no special link is required between these two accounts. You repeat the same steps for every VPC you want to add. There is a soft limit on the number of virtual interfaces you can create, but that can be increased by raising an AWS support ticket. You create a separate BGP session for each VPC. Configuring this is all very simple. When you create a virtual interface, a management console will give you a configuration file, which you can download and apply onto your router. Once you do that, and the BGP session is up and running, routes have been exchanged, you can access resources inside the VPC using their private IP addresses as if it was an extension of your data center. If you have a virtual interface connecting into a VPC and you want to access resources in a VPC peered with it. That, again, is transitive routing and is not supported. You'll have to create a virtual interface directly into the VPC and access resources that manner. Another thing we sometimes see our customer implement is called hairpinning, where you peer two VPCs using Direct Connect. So the way it works, the server sends traffic over Direct Connect back to the customer router, from where it gets redirected over Direct Connect back to a second VPC. In most cases where our customers choose to do this is because they have a corporate policy that mandates them to inspect traffic between VPCs. And it's easier for them to do so over their existing security stack. A consideration against this is that there will be Direct Connect bandwidth costs and implications around latency. You may have heard of the feature called VPC Private Endpoints. VPC Private Endpoints allows resources inside a VPC to access publicly addressable AWS services without a need for internet gateway or public IP addressing. This is currently available only for Amazon S3. Now, if you had a virtual interface into a VPC and wanted to leverage the VPC endpoint to access AWS public services, that again is transitive routing and is not supported. So the way you do it is you create a virtual interface called public virtual interface to access these AWS services. It is very similar to the virtual interfaces we discussed before in the sense that you map it with a VLAN ID and you establish BGP over that, but with subtle differences. You will require a pair of publicly routable IP addresses on your router for the BGP session to work. As part of the BGP route advertisements, we will advertise to you the entire region's IP range. This includes not only the services you want to access, like Amazon S3, DynamoDB, but all of region's EC2 public and elastic IPs as well. Think of that carefully. Any customer in the region's EC2 with public and elastic IPs will be accessible over public virtual interface. Now, one way to go about restricting traffic is to use EC2 describe prefix lists API call. This API call will give you the CIDR range of an AWS service in a particular region. Currently, this is valid only for Amazon S3. So you can use Amazon S3 CIDR range to restrict traffic only to S3. You should be mindful of the range which you are advertising to us as well, because that range will be advertised to the region's network. So any customer in the region's EC2 which is trying to hit your public IPs might be doing so over Direct Connect based on your route advertisements. While talking about AWS Managed VPN, we mentioned that BGW is represented by publicly routable IP endpoints, as well as in case of software VPN, you establish VPN on an elastic IP. Now, these ranges also belong to the IP range which we advertised over public virtual interface. What this means is that you can create a VPN connection to a VPC, and that will travel through the public virtual interface. Many of our customers who have compliance requirements around encrypting traffic establish virtual VPN tunnels over Direct Connect and access VPC in that manner instead of directly using a private virtual interface. Now, what I'm going to talk about is valid only for US regions. So with that in mind, let's bring in some of the other US regions. Now, the nuance here is that if you're connected to one of these regions through Direct Connect, and you create a public virtual interface. You receive route advertisements of that region's IP space, as well as the IP space of all the AWS regions within the United States, which means you can access resources within that region, as well as resources in a remote region over public virtual interface over Direct Connect. This includes VGW of a remote VPC, so you can create a VPN tunnel and access VPCs that way. Let's look at a different visual to further illustrate this point. Let's say you have a Direct Connect in US West 1, and you wanted to use that Direct Connect to access a S3 bucket in US West 2. Well, you can easily do that using a public virtual interface. What you can also do is you can create a VPN tunnel to a VPC in US East 1. Now, we guarantee that if you're accessing public AWS resources in a remote region over public virtual interface, traffic will only traverse through AWS private backbone and Direct Connect circuits. With that, I think you should have a fair idea about how do we access resources over Direct Connect.
I'd like to do a quick review of the things that we covered today based on the agenda that we kind of set out for ourselves. We compared and contrasted AWS Managed VPN and Software VPN. We talked about Direct Connect and the physical options that there are to connect to it. We brought up how private virtual interfaces are VLAN representations that give you access into a VPC, and public virtual interfaces will give you access to the region's publicly addressable services, and also to the VPN in that region, if that's what you'd like. We mentioned that US-specific nuance of public virtual interfaces giving you access to the public IP space of all the regions in the United States, and how you can create combinations of these offerings for the connectivity option that you need. So what that actually means is that the process of building out the right connectivity option will consist of first learning about your workloads, right? You need to ask yourself, what are the regions that they connect to? What are their requirements? Think about those things and dimensions that we talked about when we talked about the connection options, so flexibility and cost and performance and resiliency. How much bandwidth do they need? Do we have an understanding of how much data in, data out each workload will require? How sensitive are they to a break in connectivity or any degradation in performance? And then you can make an actionable plan. And as I mentioned before, a lot of customers will begin by bringing up a VPN, and in parallel, begin to work on building out the Direct Connect. You can add resiliency either with VPN or with Direct Connect, or better yet, with a Direct Connect through a second location. Adding additional Direct Connects will provide you with more resiliency and more bandwidth. And I cannot stress enough the importance of testing for failure scenarios and doing so on a periodic basis. And then finally, talk to your AWS team, your account managers, your solution architects, your technical account managers, support organization, and loop us in so that we can help you to make informed decisions about what workloads are suitable to what connectivity type. And we will make sure that you are being able to scale, resilient, and secure. All done? I promised to cover the meaning of life. Unfortunately, we ran out of time. So please come back next year, and I promise to cover that in detail. Thank you. Let me quickly go over some related sessions if anybody's interested. NET305 will actually happen tomorrow, and it will go into some implementation details of the things that we talked about today, like multiple Direct Connects. And ARC 302 is a session that we have every year about evolving VPC design, and that happens actually at 5 o'clock today. Thank you, everybody. Thanks very much.